Okay, so I feel like I'll get you started, right? Okay, so the questions, so there were a few questions from homework. I'm going to look at them and get you started. So here's your chance to review a bit. All right, so we've got question 3, excuse me, a bacteria culture doubles every quarter hour. That's my doubling time. 1/4 hour is also 15 minutes if that's what I choose to do. At a time of 1 hour and a quarter, an estimated, I'm going to ask that you don't speak while I'm taking this up. An estimate of 40,000 bacteria is taken. What is this? Is it A naught or just A? No, it's A. So, oh, sorry, take that back. Take that back. It is A naught. Oh my God. What is the initial size? No, correct. All right. A bacteria culture doubles every quarter hour. At time 1 hour and a quarter later, an estimate of 40,000 is taken. What is the initial size of the culture? So this is not the initial time. This is how much time has elapsed. Got it? So the way that we set up our equation, so we know A of t is A naught, and then we've got 2 to the power of t over d, right? Because we're always talking, so far, we've always talked about doubling time. So specifically for this question, because we're given 40,000 as the time, as the amount, so 40,000 is the amount at 1 1/4 hour. I just feel like working in minutes. I'm just going to say 75 minutes. So at 75 minutes, there are 40,000. That means we don't know A naught, but we do know that the doubling the doubling time is 15 minutes and 75 minutes elapsed. So questions about how I set this up, right? This is a really big piece. It's just setting up the equation. Lila, is this helping?
I knew how to send that, but I was confused.
What to do then? All right. So then I look at this fraction, 75 over 15. Do you know how I can simplify it? How much times does 15 go into 75? 5. All right, so I've got 40k equals A naught times 2 to the power of 5. I want to isolate A naught. So I'll get A naught equals to 40,000. I'll just write 40k divided by 2 to the power of 5. Right? Does that help? And then I don't know what we get, but that's it. Now it doesn't matter if you chose instead to use time in hours and go 0.25 and 1.25, you will still get, because it's a ratio, you will still get the exponent of 5. So it doesn't matter which unit you use as long as the unit of both times is the same. So we know that we started off with, I don't know, they gave us, we found the A naught. Okay. Then for question B and C, they're asking us what is the population at 2 hours and 3 hours. So to solve this, you have to use the original amount that you solved for in A. Is that good, Lila?
Yeah.
Excellent. Then I had a question for question 4. A bacteria culture starts with 3,000 bacteria. All right, that's my A naught. After 3 hours, well, 3 hours is T. The estimated count is 48,000. So that's going to be my amount at 3 hours, right? What is the doubling period? Ooh, ugly. Ooh. All right, well, let's fill in the equation with what we know. We know that the amount after the time elapsed is 48,000. Okay. We know that the original amount is 3,000. And then I know to write a 2 to the power of, I know the time elapsed, it's 3. The only piece I don't know is the d. I need to find the exponent. Now, this is a situation where we go back to our lesson 3, where we don't know how to do the opposite operation of exponents. The only way we know how to get a variable out of the exponent is to have the other side of the equation have the same base and equate the exponents. So let's see what we do here. Let's divide both sides by 3,000. Okay, that's going to be 16, right? 48 divided by 3, 16 equals 2 to the power of 3 over d. Oh, look, this is starting to look like that question 3 in the homework. Can I write 16 as a base 2? What is it? 2 to the power is 2 to the power 4? Okay, great. So 2 to the power of 4 equals 2 to the power of 3 over d. Can I solve for d? Yeah, it's not pretty. Okay, it's going to be 0.75, but I can do it. So when I'm at this point, I can say, okay, since the bases are the same, therefore 4 equals 3 over d. And let's take a moment to solve this algebra. I think this is, some of you are aware that you can just swap these two. But if you're not sure, I'll show you how to do that. Okay, I want to get the d out of the denominator. So I have to multiply both sides by d. Okay, that gives me 4d equals 3. And then I'll divide both sides by 4. And that gets me to d is 3/4 of an hour. Excuse me. As I said, the 4 and the d actually just swap. That might be something that you're aware. Now, 3/4 what? What are we talking about? Good, let's go to the beginning of the question. Time is given in hours, so that means it's 3/4 of an hour. Now, what is 3/4 of an hour? Okay, pause. Do you know what we're talking about? What is it? What is it? Doubling time. So that means, so if a bacteria culture starts with 3,000 bacteria, after how much time is there 6,000 bacteria? No. So to go to 6,000, that means we have doubled. How long did that take? 3/4 of an hour, i.e. 45 minutes, right? That's what doubling time means. It just means how long does it take to double? And once we're at 6,000, how much longer will it take to get to 12,000? Another 45 minutes. 24,000, another 45 minutes. Good. All right, let's look at 5. Assume the world population was doubling every 35 years. Well, that tells me that 35 years is D. Anyone see A be used as the unit for years? What does A stand for, Latin people? Annum, right? Annum is years. How about in French? What's the word for years? Ans, right? ANS. That comes from Latin. So sometimes A will be used as a unit. Annum. I don't know if it's a double N. Okay. Guys, Latin, I'm those if anyone's taking Latin, I think it's awesome. There is so much Latin in our vocabulary in science, like it comes up all the time. All right. Assume the population was doubling every 35 years in the 80s. In 1980, the total population was 4.5 billion. Okay. If the doubling period remained at 35, all right, so that would be A naught. Find the projected world population for 2020. The rate of growth has changed. It's not doubling in 35 years. That doubling time has changed. But we're saying, okay, if it hasn't changed, what will be the population in 2020? Now, I don't say A at 2020, right? Because 2020, 2000 years is not what has passed. The T is going to be 2020 minus 1980. How much time has elapsed? How much time has gone by? Right? That's going to be 40 years. So I want to know what is the amount of the population after 40 years. Well, at 1980, it was 4.5 billion, right? How much time has passed? 40 over 35. Will the population have doubled by that time? Just looking at the equation, will it have doubled? How do you know that? The exponent is greater than 1. 40 over 35. Every 35 years, the world population doubles. How many years elapsed? 40. So it doubled and then some. Okay? All right. That's a good, this is all in your notes. It's there. I made a video, so you can watch it if you need to. Did I make a video? Yeah, I did.